Welcome back to the deep dive. This week, we got something a little different. Not just a stack of articles, but, well, it's a blueprint.
It really is a blueprint for mastery.
Exactly. Our source material is a complete 15-week survey course syllabus. It's titled The World of Chiroptera. That's bats, of course. And it's designed for someone to teach themselves.
Completely self-guided.
So our mission today is kind of twofold. First, we want to pull out the core ideas about bat senses, specifically echolocation. But second, and I think this is the really interesting part, we're going to crack open the structure of this thing to show you how this curriculum is basically a roadmap for getting up to speed on a really complex topic fast. We're not just looking at bats, but how this thing teaches you to become fluent in a scientific field.
And what's so striking right away is the whole methodology. The strategy here relies completely on open access research.
Right.
Things like Bat Conservation International, PLOS ONE, the Biodiversity Heritage Library. It kind of proves you don't need a $500 textbook to build real expertise. But the real insight, the pedagogical idea, is this requirement for what they call embodied learning.
Okay, what does that mean in practice?
It means the syllabus isn't passive, it's not just reading. It actually demands that you use a physical notebook. And analog art, drawing, sketching, handwriting your notes, that slow, kind of low-tech process of writing and drawing, that's the mechanism that makes the knowledge stick. It forces synthesis.
Okay, let's unpack that structure, because I think anyone trying to learn, a new coding language or a period of history could absolutely borrow this. The course is broken into 4 months.
Yeah, 4 distinct blocks with clear goals. Month 1, so weeks 1 through 4, is called the Biological Foundation.
And it's front-loaded, right? It's all evolution, anatomy, the mechanics of flight, the heavy stuff first.
It is. And that first phase has one really critical goal, which is to establish that notebook habit from day 1. And the weekly rhythm is just brilliant. It's designed to stop you from getting swamped with information.
It's not just read about bats.
No, not at all. They have this strict 5-day cycle that forces you to apply what you're learning almost immediately.
So walk us through that daily breakdown. This feels like where the real magic is.
It starts on Monday with what they call the deep dive. That's when you're in the raw research papers. Pure information intake.
Okay.
But then Tuesday, it forces this immediate pivot to vocabulary and taxonomy. You have to define 5 to 10 technical terms. You're building the language of the field right away.
And you're not just, copying definitions from a dictionary. You have to understand the function. The syllabus lists some amazing examples. We're talking about defining the tragus. That little flap of skin inside the bat's ear. It's not just a piece of cartilage. It's a dynamic part of their sonar, essential for figuring out vertical direction.
Exactly, or the calcar.
The calcar, that tiny little spur of cartilage by the ankle, which is all about pulling the uropatagium taut.
The flight membrane between the legs.
Right, which acts as a rudder, but also, for some species, like a net to scoop up insects. You can't just know the word, you have to know what it does.
You're forced to internalize the biomechanics. And that rhythm just continues. Wednesday's the case study. You profile one species to make the theory real. Thursday is purely visual.
The visual study.
Right. You have to sketch an anatomical feature.
And then Friday is the real moment of truth, the weekly reflection.
Yes.
They mandate a 2-page synthesis written out in the notebook. This is where you have to connect all the dots yourself. You move from just consuming information to actually creating structured knowledge.
And that 2-page reflection is the hidden engine of this whole thing. I mean, it's a huge mental lift, and you could argue it risks burnout, sure.
It sounds exhausting.
But the syllabus is strategically making you be inefficient. Typing is fast. You can copy and paste ideas. Handwriting is slow. It forces you to rephrase every single concept. That slow, deliberate transfer, it just engages deeper memory pathways. It's low-tech for high-yield retention.
And that foundation you build in month 1, the vocabulary, the anatomy, it perfectly sets the stage for the core science we wanted to get into. Month 2.
Senses and large species.
And this is where the focus shifts completely to the mechanics of that signature sense, echolocation.
What's so clever here is how it links back. Remember, week 1's research focus was super broad. Evolution of flight and echolocation in bats.
Right, the big picture.
It gave you the historical context. Now, in month 2, after you have the anatomical language, The syllabus dedicates 2 full weeks to a deep, specialized study of that one sensory mechanism.
This is where it gets really granular. They don't just treat echolocation as one big idea. They break it into theory and then application. Week 5 is Echolocation I. The research focuses on the fundamentals of biosonar, the physics of it.
The clean laboratory version.
Exactly. How the pulse is made, the frequencies, how the sound goes out, hits an object, comes back to the ears and the tragus, and how the brain builds a 3D map from that.
And then immediately after, week 6 is Echolocation 2, and the focus shifts to practical behavioral application. High clutter foraging strategies in bats.
Okay, that's a huge jump.
It is. And that 2-step is so crucial. Think about the complexity. Echolocation M is a bat in an open field, a clear target. Easy.
Sure.
Echolocation 10 is the chaos of reality. It's trying to hunt in a dense forest with leaves and branches everywhere with other sounds.
You're filtering out the giant echo from the tree right next to you to find the tiny echo of a moth.
An incredible feat of signal processing. They have to use strategies like Doppler shifts to tell the difference between their own movement and the movement of the insect they're chasing. The syllabus forces you to understand those specific strategies.
From theory to complex real-world application. That's how you go from being just curious to being a technical expert.
Absolutely.
So once that core sense is really locked in, the curriculum spends the whole middle part weeks 7 through 12 on specialized diversity.
And this is where all that detailed anatomical knowledge from the beginning really starts to pay off. For instance, week 9 is a deep dive into horseshoe bats.
Okay.
And the specific research focus is Rhinelophidae noseleaf function.
The noseleaf.
This family doesn't call through their mouths. They call through these incredibly complex structures on their nose. And that noseleaf, it isn't just for show. It's a biosonar funnel. It's a focusing device that lets them direct their calls with pinpoint accuracy.
So the anatomy is directly linked to their very specific, very sophisticated type of echolocation.
The physical structure enables the sensory output. It's a perfect connection.
And this whole middle section, it just shows the staggering breadth of the order Chiroptera. You cover the huge fruit eaters, the megabats or flying foxes, who mostly use sight and smell.
Right, not echolocation.
And then you contrast them with these high-speed specialists like the free-tailed bats, the Molossidea, who are migrating at high altitudes in open air. Their use of echolocation is totally different from a forest bat.
And of course, the biggest family, the Vesper bats, the common evening bats you see everywhere. But the syllabus uses this diversity to highlight more than just anatomy. It gets into extreme social adaptations.
Like the vampire bats in week 10.
Exactly. The case study there isn't just about how they feed. It's about their incredibly complex social behaviors. Specifically, social grooming and reciprocal altruism.
So for you listening, reciprocal altruism is a key idea here. We're talking about measurable social contracts.
Literally.
A bat that fed successfully will share its blood meal with a bat that failed. But, and this is the crucial part, they mostly share with bats that have shared with them in the past. It's a social accounting system.
It's an amazing example of cooperation, and it's such a powerful contrast to, say, week 8, which is about carnivorous bats and their gleaning behavior.
Gleaning is fascinating. It's a totally different approach.
It is. These bats often don't use their echolocation to find the prey directly. They use it to listen for the tiny sounds of the prey itself moving.
Like a scorpion walking on a leaf.
Yes. They basically turn off their own loud calls and just listen passively for the target's noise, then swoop in. The syllabus makes you analyze that behavioral adaptation right alongside the anatomy.
So bring it all back to the structure of learning. That final phase, month 4, weeks 13 to 15, is where everything has to crystallize.
The capstone.
Yeah, the focus shifts completely away from taking in facts and demands deep personal application.
And this is where that embodied learning comes full circle. All those daily vocabulary lists, the weekly sketches, those Friday reflections, they all feed into 2 final high-impact assignments.
Let's hear them.
First, the final paper, a 1,500-word deep dive. But here's the catch. It has to be handwritten.
Of course it does. It all comes back to that.
That's the final enforcement of that slow, deliberate synthesis. Writing 1,500 words by hand forces you to distill only the most important, connected ideas. It's so much more effective than just typing a report.
And the other one.
The final art assignment in week 15. A detailed naturalist sketch. It needs full anatomical labels, habitat details. You're not just copying a diagram anymore.
You're creating it from memory.
You are synthesizing all the knowledge, the calcar, the tragus, the wing structure, into one original complex drawing. If you can do that accurately, you have fundamentally internalized the organism.
And we should mention, there's flexibility here, right? It's not totally rigid.
Oh, absolutely. The syllabus has a note that says the schedule is a framework, not a cage. If you find a dense topic like the mechanics of flight in week 3 a bit dry,
Well, you can swap it.
you can swap it with a diversity week that you find more fascinating. It acknowledges that for self-guided learning, engagement is everything. It lets you follow your own curiosity.
So when you pull it all together, what does this whole structure really mean for you, for the listener? I mean, the syllabus itself is a masterclass in how to get smart on a complex topic quickly.
It's a blueprint. You start with the deep evolutionary history in week 1. You systematically build the technical language. You dedicate focused time to a specialized sense like echolocation.
And then you apply all that across this huge global diversity of species. It's just a methodical path.
It's the difference between, reading a Wikipedia page about bats and actually being able to explain the morphological adaptations of a horseshoe bat's nose leaf for foraging in high-clutter environments.
Absolutely. Okay, so we spent a lot of time on the sensory mechanics and the structure of learning. But here's a final thought for you to explore next, and it's built right into the syllabus. Beyond the physics of flight and echolocation, Week 13's research topic is the economic impact of bats on agriculture.
A huge topic.
A huge topic. So when you consider their massive role in controlling insect populations and pollination, what are the implications of that measurable financial value for conservation policy, for how we decide to fund future research?
It's a deep dive in itself.
It really is. That's one for another time. We'll see you next time with a fresh stack of sources.